Hey guys, it's me coming to you from the home office. Also a mess, still working on the house, right? Okay, so if you were around on Thursday the 14th when we did the Google Meet for class, I read you an epic fairy tale of drama and intrigue written by me. And don't worry if you missed it because I'm going to read it to you again today. But we also reviewed the concept of a hydrosphere, right? We know that Earth can be broken into four spheres based on the materials that make up Earth: the biosphere, all the living things; the atmosphere, all of the gases, right? Atmosphere, you should probably know that one. And then we talked a little bit about the hydrosphere, which is all of the water based materials, right? Water, snow, ice, what's up in the clouds, what's collected on the ground, and what's in the process of going through the cycle. And then we reviewed the water cycle, which is something you did in elementary school. And there was a neat little diagram that you filled in with the text box on the Nearpod. Please go back if you did not do that and complete it so that I can give you credit for the work. And now I want to move on to the lithosphere, right? We know that litho is a prefix. It comes from the Greek word lithos, and it means stone or rock. So the lithosphere is actually all of the rock material contained in the surface of the earth, right? Now, the earth is made of layers, and we're going to talk about that more another day. That has to do with density of materials. But for now, I just want to talk about the outer shell of the earth. So I want you to think for a minute about a hard boiled egg. And when you're ready to crack and peel that egg, how very thin the shell is compared to the rest of the egg. That's a really good visualization for you to understand about Earth's crust, right? The hard surface of the Earth that we and all the living things exist on or in is extremely thin compared to the Earth as a whole, right? The Earth is massive, and it's real easy to forget how massive the planet is, right? So the drawing that I have here is not to scale, but I wanted you to be able to see lithosphere, right? So the black bumpy area constitutes Earth's hard crust, right? That's the part that we exist on. And all the soil and all the rocks and all the dust and sand is all part of that crust, and that is all considered part of the lithosphere, as well as what's known as the upper mantle, what you guys would think is the lava just beneath the surface. Now, notice the Earth's lithosphere is not even all around the planet, right? We've got some high points, like mountain ranges, and then we have some low points, like oceans, right? I tried to draw an ocean there. Can you see that? The blue is the ocean, right? Now, the ocean's part of the hydrosphere, but I want you to understand that the water's collecting in certain places on Earth simply because the lithosphere kind of has a dent in it there, right? It's also thinner, right? The bottom of the ocean is going to be a thinner part of the lithosphere than the rest of the planet, than, say, thicker parts like where mountains would be, right? And what the other thing you should understand is that the earth material, the rock material under the ocean, is actually a lot denser than the rock material we're walking around on, simply because water's pressing on it all the time, right? So if I took this towel and I laid it on my board, and the towel represented Earth's crust, right? And then I took this good old jar of water, which is going to be the ocean, okay? And I put that there. You can clearly see same towel, same amount of material, right? But compressed, right? Compressed simply because of the ocean laying on top of it. So that is why we know that the ground under the oceans is the material there is denser. It's more pressed on and compressed than the rest of the lithosphere. Okay. So all the rocks you can think of, all the minerals you can think of, every grain of sand, almost every bit of soil. I won't say every bit of soil, because soil is also made, it's a combo thing made of non-organic rock material and dead stuff, right? So that all makes up the lithosphere. And here's the cool thing: the lithosphere is almost fluid, right? To you and I, it's this giant rigid thing and we walk around on. And as people, as puny humans, we have no power to mold this part of the earth. But believe it or not, it's always being molded because the forces, the geological, that's the word. Geo is a prefix for earth. So the earth forces, the geological forces of the planet are constantly changing and molding that lithosphere. Not to say we don't have power over it. Even the littlest animals have some molding power over the surface of the earth, but generally it is those geologic forces at work that are molding the surface of our planet like clay all the time, and it's always changing. This stuff happens over sometimes millions of years, right? Geologic time is like this, like a second to geologic time could be generations of your family, right? Everything is relative. So the reason we don't always see this molding of Earth's surface happening is because it's happening so excruciatingly slowly, we can't witness it happening. All right? Let's take a little tour and look at some evidence of that molding.